All right, let's talk about the segment addition postulate. So what that really basically says is that if you have a line segment and it's broken up into pieces, then the pieces add up to the same distance as the entire thing. So like if this was 3 and this was 4, then the entire thing would be 7. And that's what this formula right here shows us, right? If you have the two pieces, then they add up to the whole. So right here, AB plus BC equals AC. So the two little parts add up to the whole thing. And we can use that fact to figure out different distances and, well, all kinds of stuff. So let's say, for example, here, let's do another one like this. Let's say this is C right there. Now let's say that's B. This is A, and this is C. So this is a B, a very ugly B. Now, let's say this was 2 between, so let's say AB was 2, and let's say AC was 7. Well, then what would BC have to be? Well, AC is the whole thing, and this part's 2, so that means this part would have to be 3. That's how it works. Or if you had something like this, let's say A, B, C again, but let's say this time you knew that AB was 4, and let's say this time you knew that BC was 10, and you had to figure out AC. So the tricky part is you have to figure out what it's asking for. AC starts here and ends there, because with line segments, I guess I should use the proper notation. With line segments, it's got the bar on top. The two letters you see, those are the endpoints, right? So let's brighten this up a little bit. Those are the endpoints. So if we have this is 4 and this is 10, then the whole thing is 14. All right, now let's see some that have a little bit of algebra here. So on this one, we have to figure out, what does x equal? Well, 6 plus this equals that. So 6 plus that equals that. So we can write an equation for that. So 6 plus 2x plus 15 is going to be equal to x plus 15. See how that works? All right, so we can solve this. We got to put these two things together right here. So 2x equals 21 equals x plus 15. So let's go ahead and move the x to the other side. So x equals, we'll subtract 21. X equal, that's a 1. X equals negative 6. There we go. That's how it works. Now let's see another example right here. It says Km is 20, KL is 80, NL is 10, and we have to find MN. So let's start off with what we need to find. We need to find this distance right here, M to N. Now we know K to M is 20, so I'm going to put that in there. We know K to L, that's the whole thing, is 80. And N to L, this part right here, is 10. We have to figure out that part. Well, check this out. The whole thing is 80. These two make 30, so this has to be 50, right? Because 80 is going to be equal to 20 plus 10 plus MN. I should put my bars on top, right? So 80, oh, my handwriting's pretty bad, equals 30 plus MN. So subtracting 30 from both sides, you can see that 50 is what MN equals. So that's how the segment addition postulate works. You've got to write out your equations, but the basic idea is that the parts add up to the entire thing. So I hope this has been helpful, and I hope you have a great day.